Look at the skyline of any major city in Uganda today. You'll see massive, multi-story buildings that stack homes and offices hundreds of feet into the air, all of them held up by heavy materials. Inside our large cathedrals, you see something even more impressive. Massive, open spaces without a forest of thick pillars in the way. It raises a question. How exactly do you keep a roof that heavy from crashing down? For most of early history, builders relied on two upright pillars with a flat stone beam resting across the top. It was the standard way to bridge a gap, but it only worked for small spaces. Flat stone has a weakness. If the pillars are too far apart, the beam in the middle can't support its own weight. It begins to sag and eventually snaps right down the center. Over 2,000 years ago, engineers in the Roman Empire solved this problem, changing the way we've built everything ever since. To understand how our modern cities stay standing, we have to look at the Roman obsession with building things that were meant to last forever. The Roman solution was a geometric trick that essentially redirects the pull of gravity. They perfected the arch. Instead of a flat beam, they used a curve made of wedge-shaped stones. This shape takes the heavy weight of the roof and pushes it outward, away from the center. Those outward forces are then steered straight down the sides of the structure and into the solid ground, making the whole thing incredibly stable. When you line up a long row of these arches, you create a vaulted ceiling. This let the Romans build massive, open rooms without a single pillar in the middle to block the view. You see this ancient logic every time you look at the curved brick windows and high ceilings of Ugandan landmarks like Namirembe or Rubaga Cathedral. The arch turned construction from a game of stacking blocks into a sophisticated way to manage physical force. But carving thousands of perfect stone wedges for every new project was slow and expensive. To speed things up, the Romans mixed volcanic ash and lime with rubble and water. They created a liquid stone that could be poured into any shape and left to dry. They had invented concrete. This cheap, flexible material allowed them to build on a scale no one had seen before, like these towering aqueducts that used a series of arches to carry fresh water for miles into the heart of their cities. Poured concrete freed builders from the limits of carved stone, paving the way for the multi-story urban world we live in today. This focus on durability didn't stop at their buildings. It extended to how they portrayed their people. Earlier Greek artists tried to make people look like perfect, youthful gods, flawless and beautiful. But Roman leaders wanted to be shown exactly as they were. They kept the wrinkles and the scars in their stone portraits because they believed those details showed the wisdom and authority of a life spent working hard. To decorate their thick concrete walls, they brushed paint directly into wet plaster. As it dried, the colors bonded with the wall itself, becoming a permanent part of the building's physical skin. From their realistic statues to their bonded wall paintings, Roman art was engineered to project power that wouldn't fade over time. Today, the Roman Empire is long gone, leaving behind only these weathered skeletons of brick and stone. But the engineering they mastered is still very much at work, supporting the massive bridges that span the River Nile. Every time we pour a concrete foundation for a new skyscraper in Kampala, we are using the same chemical principles the Romans discovered. Every wide hall or place of worship that relies on an arch to hold up its roof is a testament to their blueprint. Ancient Roman history lives in the curves and the concrete of our own neighborhoods, quietly doing the heavy lifting in every city we call home today.